video I want to discuss ions and isotopes. Two key words you'll hear plenty when doing the atomic structure topic, but do you know what they are? Can you define them? Can you work out what they would be? So I'm going to deal with ions to start with. Very briefly, we learned before that there are, for neutral atoms, the same number of protons and electrons. So for example, lithium would have 3 protons and 3 electrons, and we can work out the number of neutrons by doing 7 take away 3. So it would have an electronic configuration of 2, 1. Likewise, if I had fluorine, which has got 10 protons and 9 neutrons, that would have an electronic configuration of, fluorine's got 9 protons, 9 electrons and 10 neutrons, so 2, 7 will be its electronic configuration. Now, when lithium and fluorine form ions, they go about it in different ways. Okay. Essentially what happens always is that you end up with the atoms either losing or gaining electrons to form full outer shells. We can have the idea that atoms, when they have full outer shells, they are stable. And this is true for atoms like helium, for example, which has an electronic configuration of simply 2 because there's 2 in its outer shell, or argon, which has 8 in its outer shell. So those shells, shell 2 and shell 1, are filled in those examples. So these noble gases are stable. We'll look at those in more detail another time. But to form a full outer shell here, lithium's got a choice of gaining 7 electrons, to be 2 then 8, or losing 1 electron. Now, the way that this works very simply is the atoms will lose or gain as few as possible to make a full outer shell. So in the case of all metals, they will lose electrons to form ions. So lithium will lose 1 electron and form a lithium 1 plus ion. It's now still got 3 protons, but it's only now got 2 electrons. So overall it's got a 1 plus charge. It's worth remembering that metals always form positive ions, and you can remember that because the word metal has got a plus conveniently right in the middle of the word. Now, a fluorine atom will form an ion. It could in theory lose 7 electrons. That requires a lot of energy, and it's much easier for it to simply gain 1 electron, so it forms a fluoride ion. Now when non-metals change to ions, they always change their name to ide. Fluoride, oxide, phosphatide, nitride, sulfide, bromide, all of them, they change their name to ide. So this would become 2, 8. It gains 1 electron to fill that second outer shell, and it's now got a 1 minus charge because it's still got 9 protons if I draw them all quickly, but it's now got 10 electrons, and so it's got 1 more negative charge than it does have positive charges. And conveniently, the word non-metals has got a minus in the middle of the word. So it's worth remembering that all non-metals, which are on the right hand side of the periodic table, remember, always form always form negative ions. We could do that also with elements that are in group 2, such as magnesium. So magnesium's got an electronic configuration of 2, 8, 2. There's 2 in the outer shell. It's a metal that's going to lose 2 electrons and forms a magnesium 2 plus ion. So the electronic configuration is 2, 8, and that's a magnesium 2 plus ion. We would draw that, by the way, by putting a magnesium ion in square brackets, and we'll show its charge by putting a 2 plus there. And an oxygen atom, which has got 8 protons and 8 neutrons and 8 electrons, so 2, 6, it would form an oxide 2 minus ion. It's a non-metal, so it's going to form a negatively charged ion by gaining electrons, fill that second shell, make it up to 8. It's going to have a new electronic configuration of 2, 8, and we would draw that. It would look very similar to this one, of course. and we'd have 2 in the first shell, 8 in the second shell. This time we've got a 2 minus ion.